Hey everybody, today's new lesson is on equivalent fractions. So talking about fractions, and we want to talk about what this word equivalent means. And basically you can almost even see it in the word here, because it starts with kind of the word equi, or what that is going to be is pretty much that means equal. Okay, we're talking about fractions that are equal, fractions that have the same value. So let's start with a pretty basic one that we all know, something like a half. Okay, first thing I want to point out, and these are terms that we know already, but we'll say it again, is that this top number, we don't call it the top number, we call it the numerator. Okay, the numerator is going to go on top, and the denominator is what we call the bottom number. So we'll write that down just as a refresher. Okay, and basically when we're writing equivalent fractions, we're trying to find fractions that are equal to each other. So if I'm talking about the fraction 1/2, well, I know that one fraction that's equal to 1/2 is 5/10. 5/10 is also equal to a half. They have the same value. And basically the way we do this is that since I know these two things are equal, is one thing I want to do is I can multiply or divide whatever I want by the numerator. So if I want to take that 1 times 5, that's what gives me 5. But the rule is, if I multiply by 5 on top, I have to multiply by 5 on bottom, and that's how we get the 10. So that's how I know that those things are equal. Alright, so that's if. Now, that's if you're multiplying by 5. You don't have to multiply by 5, though, on the top and bottom. What if I chose a different number? Well, we could choose any number that we want. So instead of multiplying by 5, what if I pick 10? Okay, then I would get 1 times 10 is 10. But then since I multiply by 10 on top, I can multiply by 10 on the bottom. 2 times 10 gives me 20. So that's another equivalent fractions. And again, like I said, you could really multiply by anything. So if I didn't want to multiply by 10, what if I wanted to multiply by 9? Okay, it's just the key is whatever you do to the top, you have to do to the bottom. So then I would get 1 times 9 is 9. 2 times 9 is 18. That also equals a half. Matter of fact, if you start with a fraction like 1/2, one trick that you could do is just add a bunch of zeros. 1, 2, 3, 4. Well, then I'd have to add 4 on the bottom. 1, 2, 3, 4. So these are all equivalent fractions because they're all equal. Equivalent fractions. And like I said, that's because they are equal. And that's the whole key to today. We're trying to find fractions that are equal in value, and we're just going to change them from one form to another form. Okay, example 1. Write two fractions that are equivalent to 6/8. So I'm going to start by rewriting this. 6/8. And if I'm going to write something that's equivalent to this, so I have to find something that is going to be equal to 6/8. Okay, and the first thing I'm going to say that we can do is just simply to reduce the fraction. So what I'm looking at here is the 6 and the 8, and I'm trying to find a number that I can divide both the 6 and the 8 from. Now that goes back to our divisibility rules. Trying to find a number that I can divide 6 by that I can also divide 8 by. The first thing I notice is that both the 6 and the 8, well, they're both even. And if they're both even, well, that tells me I can divide by 2. So if I take the 6 divided by 2, that's going to give me 3. Okay? But then again, our rule is whatever you do to the numerator, you also have to do to the denominator. So 8 divided by 2 gives me 4. So write two equivalent fractions. Well, I have one already, 3/4. Okay? Now, it does say that I have to find two of them, so I have to do something else. Well, I can't reduce it again. So one thing that we do is instead of reducing it to finding equivalent fractions, so instead of dividing by a number, we can go the opposite way, which is to multiply by a number. And really you can pick any single number that you want. So let's just say that I choose to pick, well, let's multiply by 8 here. Okay, 6 times 8 is 48. But the rule is whatever I do to the numerator, I have to do to the bottom. So I have to do 8 times 8 on the bottom, which gives me 64. So 6/8 is also equivalent to 48 over 64. And those are two answers. They're not the only answers. There are unlimited possibilities of what you can do. I didn't have to multiply by 8 here. I could have multiplied by 2, multiplied by 3, multiplied by 4, any number you can think of. So a couple other possibilities. If I multiplied by 2, I would have got 12/16. If I would have multiplied 6 and 8 by 10, I would get 60 over 80. Okay, if I just started adding a bunch of zeros, how about 6,000 over 8,000? I could even multiply by 11. 6 times 11 is 66. 8 times 11 is 88. Those are all possibilities. All we need to do is come up with two of them. We don't have to do all of them. Okay? So two fractions. Two ways to do it. One way is to reduce, and the other way is to actually multiply and make the numerator, denominator actually go up. Okay. Write each fraction in simplest form. And I want to point out here, when it says simplest form, that's something that we need to know. When it says simplest form, that is specifically telling us reduce it. Simplest form is to make these equivalent fractions, but we want to make them the smallest numbers possible. Now, what the experts in math are going to tell you is that what we should do, if I'm going to do this part A first, 8 over 28, what the experts tell us is that we should come up with the greatest common factor. And if we did the greatest common factor, one way to do that is to list factors like 1 and 8, 2 times 4, and that would be all the factors there. For 28, I would get 1 and 28. We would get 2 and 14, and we would get 4 and 7. So the greatest common factor would be 4. Okay? The GCF is 4. And when you're reducing, one way to find something to put it in simplest form is to divide by the greatest common factor. So since the greatest common factor is 4, one thing I could do is divide both top and bottom number by 4. So 8 divided by 4 is 2. 28 divided by 4 is 7. So you get a final answer of 2/7. Now that's a great way to do it. I don't want to knock that. It's a great way to do it because it gets you your answer in simplest form in just one step. I only had to do one thing to get that answer of 2/7. Okay? Now the problem is that realistically, nobody does it that way. Okay? So what I want to show you is the way that you're probably going to do it, 8 over 28, is just like I did in example 1, which is to find a number that both 8 and 28 can be divided by. And the first thing that might jump out to you is that they're both even numbers. So if I divide them by 2, 8 divided by 2 is 4. 28 divided by 2, because it has to be divided by the same number, it gives me 14. But then what you have to realize is that 4 over 14, that still isn't in simplest form because I can divide both the 4 and 14 again. Because they're still both even numbers, if I divide by 2, 4 divided by 2 is 2, 14 divided by 2 is 7, and you'll see I'll end up getting the same answer. It's just I kind of had to reduce twice. I had to reduce right here by dividing by 2, and then here again divided by 2 to get my final answer of 2/7. I'm going to erase that because I only want my answer circled there, 2/7. Okay, I'm going to let you guys pause it. I want you to try part B on your own. So 12/18, pause the video, and reduce it. Okay, hopefully you're back. So 12/18, you should be thinking, okay, what can both the 12 and the 18 can be divided by? There's a couple possibilities here. One thing that you might see is that, again, they're both even. So let's divide by 2. And if I divide by 2, 12 divided by 2 is 6. 18 divided by 2 is 9. But now you got to check this answer out here. I'm going to write 6/9 again. And what I notice is that it isn't in simplest form because I can still divide again. Both top and bottom have a common factor of 3. 6 divided by 3 is 2. 9 divided by 3 is 3. To get a final answer of 2/3. Okay, now I'm going to write over the top here because some of you guys might not have divided by 2. What you might have saw was right away, well, 12 and 18, we know that 6 can go into both of those. And if you do 12 divided by 6, you're going to get 2, and 18 divided by 6, you get 3. So if you find the largest number possible right away, there's going to be less steps involved. Okay, so whichever way you want to do it. Okay, last one here, 8/15. Okay, if we do 8/15, you're trying to think, well, what can go into both 8 and 15? Well, I know 8 can be divided by 2, but 15 can't be divided by 2 because it isn't even. So you can't do that. I know 8 can be divided by 4, but 15 can't be divided by 4. I know 8 can be divided by 8, but I can't do 15 divided by 8. So in this case, I've tried all the factors of 8. It doesn't help me divide by 1 because then I'm just going to get 8/15 again. So I don't want to do that. basically in this case, since they don't have a factor that can go into both 8 and 15, then we just say that this one already is in simplest form. Okay, so we don't have to do anything, already in simplest form. Okay, and that's all we're doing. Okay, so reducing is dividing it down as far as we possibly can. Okay, example 3, last one here. Tell whether the fractions are equivalent fractions. So, in this case, there's an A and a B. I'll do part A, you can do part B. But if they're asking me, they're simply saying, are these two things equal to each other? Okay, not the denominators, but the entire fractions. Is 8/12 the exact same thing as 18 over 27? So, what we have to do is reduce both of these down to simplest form. And if we put them in simplest form, they should equal the same thing. So let's start with 8/12. If I'm going to reduce this, okay, I notice right away that 4 goes into both 8 and into 12. And if I do that, 8 divided by 4 is 2. 12 divided by 4 is 3. 2/3 is the simplest form that I can get. So let's switch gears here. I'll do another color, and let's do the 18 out of 27. Okay, I notice that, okay, 3 goes into both of them. So let's divide by 3. 18 divided by 3 is 6. 27 divided by 3 is 9, but that isn't reduced yet. I can reduce them by 3 again. 6 divided by 3 is 2. 9 divided by 3 is 3. And look at this. Those two things, when put in simplest form, end up being the exact same thing. So they're asking, tell whether the fractions are equivalent fractions. My answer is yes, they are. Now, I expect to see all of this work here for your answer. I need to see the work, but your final answer is going to be yes, that they are equivalent fractions. All right, you guys pause the video, try part B, telling me if they're equivalent or not. Okay, you're back. So, again, to prove if something is equivalent is we have to reduce both fractions. So let's start with the 14 over 22. I notice that they're both even. 14 divided by 2 is 7. 22 divided by 2 is 11. That's as simple as it can go. Now let's move on to the 10 over 25. Well, I notice that both of these numbers end up in either a 5 or 0, so that means they can be divided by 5. So I'm going to use my divisibility rules to figure out they can be divided by 5. 10 divided by 5 is 2. 25 divided by 5 is 5. These two things, 7/11 and 2/5, when they're put in simplest form, are not the same. So this way, no, they are not equivalent fractions, because to prove they are, when you reduce them all the way down, they should end up being the exact same fraction. In this case, they're not. Okay, that's our lesson.